Alright guys, in this video we're going to be doing complex numbers. And mind you, complex number, this video is going to be in series. I'm going to be dropping about 13 videos on this topic to explain more on complex numbers. So I want you to watch it video by video so you can get the full context of what I'm about to teach. Now, introduction to complex numbers. Oftentimes, before now, the knowledge of real number system must have been passed across, even at senior basic levels. We define real number system as the real number that embraces all other systems, and such as integers, rational numbers, and irrational numbers, even set of natural numbers. Now, more than all these numbers that we have mentioned that are embedded in the real number system, there is still an extension in the field of real numbers. When we have this like this, let's say this is a field, and we have, let's say this is set of natural numbers. Okay, we have set of natural numbers here. We have the set of integers here, integers. Okay, then we have set of rational numbers. Okay, they will now have a real number that's embracing everything. Now, more than all this, we still have an extension that goes on and on away from this place, and that is what we now call complex numbers. So complex number is an extension of the real number system. So quickly note that, because that is very, very important in this class. Complex number is an extension of the real number system. Okay, so in that case, let's give a confined definition of what a complex number is. A complex number, this, okay, is defined as any number written in the form z is equals to x plus yi. Okay, a complex number is any number that can be written in the form z is equals to x plus y, right, where x and y, they are real numbers. X and y are real numbers. Now this x here is known as this x here, that means the number without the I is known as the real part. The real part. Why this y here is known as the imaginary part. Okay, so x is the real part of the complex number, and r and y is the imaginary part. So, and you can write this as this x, we can write it as what? The real part of z, while the y is the imaginary part of z. So you can write it this way. I'm just giving you the concept because this video is just to explain each concept. Now, having known that complex number is an extension of the real number system, and also is any number that can be written in the form x plus yi, we also know, we need to know the forms of complex number. What are the forms that we can represent complex number? There are three forms. Okay, number one form is the rectangular form. The rectangular form. Okay, I'll explain that one after the other. The rectangular form, that's the first form. Now the rectangular form is written like this: z is equal to x plus yi. Just what I finished writing as a representation of complex number. That is how we represent a complex number. That's the what's it called? Rectangular form. The second form where we can represent a complex number is called the polar form. The polar form. Okay, the polar form is written this way: z is equals to r into cos theta plus I sine theta. Alright, the third type of the form where a complex number can be represented is known as the exponential form. The exponential form. Okay, the exponential form. Now this exponential form is written like this: z is equal to r e the power of I theta. So I'm going to be explaining all this in subsequent videos, right, so we can get what each of this form represents. Okay, Now we know we have three forms: rectangular form, x is equals to x, z is equals to x plus yi, polar form, and exponential form. Okay, let's go on to identify. Let me give you an example so we can know how to identify the imaginary part as well as the real part. Number one, let's say we have 2 plus 5i. Okay, what is the real part here? The real part is what? 2, because it does not have I. Then the imaginary part is what? 5. Very simple. What if we have something like this again? If I have 4 plus 8i, what will be the real part? The real part will be what? 4, because it does not have I. Then the imaginary part will be what? 8. What if we have another example like this? If I have minus 4i plus 5i plus 3, what will be the imaginary part? You can't conclude yet. You have to work on these two guys. Okay, that will be I plus 3. So my imaginary part here will be 1, right? Because the coefficient of this one is 1. So whereas imaginary, okay, and this one will be what? The real. It's very, very simple. One more. Let me give you one more. What if we have something like this? If I have 3 plus 7i, what will be the real part? The real part is what? 3. This is the real part here, and this is the imaginary part. So you see how it's very simple. Okay, so let's go on to get the derivation of complex roots. Let's quickly do that so that can get to understand what is required more. You know that a quadratic equation is given by this: x is equal to minus b plus or minus square root of b squared minus 4ac, okay, over 2a. Alright, now we can also rewrite this in a short form as x equals to minus b plus or minus square root of what? D over 2a. Now if your d, okay, if your d is greater than 1, listen, when your d is greater than 0, actually, when d, note all these words, when d is greater than 0, we'll see that this equation has what? Has a real and distinct root. Okay, real and distinct root. But when your d, okay, when your d is equal to 0, what will you say? You see that it has a what? An equal root. The quadratic equation has equal root. Don't forget. But when your d otherwise is less than 0, probably you have a negative value, then you say you have a what? A complex root. And that's what we are dealing with in this video: complex numbers. Okay, and as a complex root, we'll be having something like this. We have x is equal to minus b plus or minus d over what? Over 2a. This is a complex root. Okay, in such situation where we have a negative sign in our roots, we can just say that it does not exist, just the way we were told when we were in secondary school or in primary school that it is impossible. But now we know that with the knowledge of d less than 0, it is what? It's a complex root, and that's what we're going to be working with. Okay, so this is where the knowledge of complex number, this is where it comes in. All right, now we know that we want to derive how we got that I. Actually, that's what we're trying to do. So I have something like this. For roots minus d can be written as well as the root of minus 1 times d, isn't it? And according to the rule of third, I can see this is minus 1 times root d, isn't it? Now here in complex number, we call this root of minus 1, we call it what? We call it I. Note that we call it I. Therefore, the root of minus d is equals to what? I root d. So So this is what we want to know, and this is what we want to know also, that the root of minus 1 is equal to what? I. Some textbook will write J, some engineering textbooks, reason known to them, and I think because I is actually used for current, so they don't want to mix things up, so they just have to use J. So they won't be using I for current, and they'll still be using I for complex numbers. So they decided to start using J as their representation, the graph. So that's how we want to work with complex numbers. So root of minus 1 is I. Let's go into the operation of complex roots. Now this is a complex root, right? When d is less than 0, we call it what? Complex root. Don't forget. So let's go into the operations of complex root. Operations of complex root. Operations of complex root. Operations. Now, suppose you have I raised to power 2. Don't forget that our I is what? Our I is the root of minus 1. So this means I'll have minus 1, okay, times what? Minus 1. What does that mean? This means that I have minus 1 raised to power 1 over 2, right? Times minus 1 raised to power what? 1 over 2. And with your indices knowledge, you have minus 1 into what? 1 over 2 plus 1 over 2. And that is 1, right? So I have minus 1 raised to power 1. Therefore, I to the square is equal to what? Minus 1. Know this. And to cut all story short, if I have root of minus 1 squared, it's still the same thing as writing this cancel this, and that is still what? Minus 1. You should know that. What if I have I raised to power 4? If I have I raised to power 4, what will you have? You will have something like this: minus 1 to the power of what? 4. Okay, this means that I can as well write this as minus 1 into power 1 over 2, right? Raised to power 4. And from the law of indices, we know that a raised to power n power m is equals to amn. You can multiply it, right? So in that case, I will have this minus 1 into 1 over 2 times 4. All right, and this will be 2. So minus 1 to the power of 2 is what? Is 1. Therefore, this I raised to power 4 is what? Is 1. That's how we do the operations with complex roots. But assuming we are given something very large, something very, very large, that you can, that's like I raised to power 2022, I raised to power something very large, you can't start thinking. There is a particular formula you can use to do this operation, and you will still get your correct final answer. So I want to teach you shortcuts on how to get a complex root, the value of a complex root, regardless of the power. Okay, so these are the shortcuts. 4n is equals to 1. 4n plus 1 is equal to I. Okay, 4n plus 2 is equals to minus 1. 4n plus 3 is equals to minus I. If you can get hold of this into mastery, you are good to go in getting your complex root, because once you can express the power in terms of multiple of 4, your answer will always be 1. Once you can express your power in multiple of 4 plus 1, your answer will always be I. Okay, let's get an example to see what I'm talking about. Suppose I have I raised to power 5. I raised to power 5. I can also write this as I raised to power 4 times I raised to power 1, isn't it? And this is like writing I to the what? 4 times 1, right? Plus 1, isn't it? And that is correlating with this one. Definitely this one will be equal to what? I. Very simple. Do you get that now? Suppose I have another thing like I raised to the power of 19. Okay, that will be what? I to the power of 16 plus 3, because the multiple of 4 is 16, so I have 4 to the power of 4 plus 3. That means this n is this 4 here, this n that you are seeing here is that 4, and this is the plus 3. So anyone 4n plus 3 is minus I. Okay, and if you want to do that, if you want to really check if it's correct, I can have 4. This is I here, right? So it's to the power of 4 to the power of 4 again, and we know that this one naturally will give us 1. Okay, this one, since it's a multiple of 4, to give us 1, so the whole of this will be 1 already. Then times I raised to the power 3. I raised to the power 3 is the same as writing I raised to the power 2 times I raised to the power 1. I raised to the power 2 normally is minus 1. Minus 1 times I will still give you what? Minus I. So that is how I got this minus I here, and it works with this one. So you can work as many as you want to. Let me get a very, very large power. Let's see if it works with it. If I have something like this, I raised to power, let's say I have I raised to power 2022. How do you solve this? I raised to power 2022 is very simple. It's the same as writing I to the what? Power of 4505, okay, plus 2. Okay, since it's plus 2, we are going with this. That will be what? Minus 1. The answer will be minus 1 here. So whenever you are given any question with a complex root with power, first thing you want to do, if it is very large, divide it by 4 and bring out the remaining as a plus. Then you get a final answer. So in the subsequent videos, I will be showing you addition, subtraction, multiplication of complex numbers, and other operations that regards complex number.